Hello guys, welcome back to my channel Maths for All by Saurav. Today we'll be learning the coordinate geometry. Okay, and this is our agenda. We will be representing how to represent the points or any shape into the graph, how to calculate the distance between two points with using the distance formula, and we will also driving this distance formula and the validation of the different shapes and figures in our graphical representation, and some section formula, how one point divides the 2 points in the ratio, and we will also driving the section formula and some examples. Okay, so what is the coordinate geometry? Coordinate geometry is a branch of the mathematics where we're dealing with the geometrical figures, okay, and we are drawing those figures into the graphs. Okay, so this is represented using the Cartesian system x and y. Okay, axis. For example, this is an x and y. Okay, this is x-axis and this is y-axis. Okay, now so any point, right, any point xy here, this can be represented as x and y, where x is abscissa and y is the ordinate. What is abscissa and ordinate? Abscissa is the first point here, which is the distance from the y-axis, and y point with the distance from the x-axis. Okay, this is a perpendicular distance. For example, this point x and y, if you draw the perpendicular here, right, and this y, you draw a perpendicular to the y-axis, so this distance is the x, which is the first coordinate. Okay, and this distance is the y, okay, the second coordinate. So this is abscissa. Okay, and this is our ordinate. Okay, so any point we can represent it into the graph using x and y. Okay, so in our previous chapters we have learned the linear equation, right, and quadratic equation. So let's understand how to represent those algebraic expression into the graphs. Okay, for example, this y is equal to ax plus b. Okay, so this is our linear equation. Okay, so means it's an equation of a straight line. So for example, this one. Okay, so this is y is equal to ax plus b. So this is our straight line. Okay, this is how we represent it to the graph. And for example, this one, y is equal to ax square plus bx plus c. Okay guys, so this one is a polynomial of degree 2. Okay, so how to represent this line into the graph? This is kind of a parabola. Okay, for example, this can be this one or maybe this one, or and like a and parabola here in the coordinate geometry. Okay, so we will be understanding how to draw this this equations, right, this lines into the graph using the coordinate geometry. So coordinate geometry is a branch of the mathematics where we representing the algebraic expression into a graph. Okay, and any point which we can represent it as a x and y. X is the distance from the y-axis and y point is distance from the x-axis, and their signs, right, positive, negative, will represent in which coordinate, which quadrant this point will fall. Okay, for example, in this x-axis and y-axis, this is our first quadrant where the first abscissa is positive and the ordinate is also positive. In the second coordinate, if you see guys, so here we are coming here in this direction, so this is negative. Okay, for example, this is x dash and x, and this is y dash and y. So here is 0, 0. So if you go here, it will be positive, and if you go here, it will be positive. For example, let me draw a point here, 1, 2, 3, 4, like that. And here if you come, it will minus 1, minus 2, minus 3. And if you go here, right, plus 1, plus 2, plus 3, plus 4, and so on till infinity. Okay, here it will also go infinity. And if you go here, minus 1, minus 2, minus 3, until minus infinity. Okay, here it will go minus infinity. Okay, now you can see, right, when you go the x-axis, right, this is x point and this is y point. So when you come, this is the positive direction and this is also positive. So any point which is fall here in the first quadrant will be positive and positive. Now here the x first point, right, first abscissa is negative and ordinate is positive. So this is minus comma positive. Okay, all the points in this section will be in the form of minus and plus, like minus 3, 2 example. Okay, and here example is any point positive and positive, you can say 3, 2. Okay, so it will lie somewhere 3, 2 here, and here minus 2, minus 3, 2 will be lie here. Okay, now understand in this quadrant, this is our quadrant 3, right? In this you can see, right, x-axis is negative, y-axis is also negative, both are negative. Okay, both are negative. So for example, minus 3, minus 2. Okay, it will be minus 3, minus 2 will lie somewhere here. Okay, now both are negative here in third quadrant. Fourth quadrant, you can see x-axis, x point is positive and y is negative, right? So any point lie here in the form of will be plus comma minus. Okay, for example 3 comma minus 2, let's suppose. Okay, 3 and comma minus 2. Okay, it will lie somewhere here, 3 comma minus 2. Okay guys, now understand how to do the algebraic equation into the graphs. Okay, let's suppose a line. First take example, a line y is equal to mx plus c. Okay, this is a line. Okay, how to draw this line on the graph? Okay, so you can say if you put x is equal to 0, you will get y is equal to c. Okay, c is any constant, so first coordinate will be, and when you put x is equal to 0, y is equal to c, and if you put y is equal to 0, okay, so x will be minus c upon m. Okay, so this is a generic equation. Okay, so 0 comma c, for example 0 comma c will lie somewhere here. Okay, c is anything, right? Positive, negative. If c is negative, it will come down here, right? And if minus c upon m, so let's suppose minus c upon m comma 0. Okay, now if you draw this line, so this is line our y is equal to mx plus c. So any points which fall on this line, right? If you write, this is a graphical representation, so any point, this one, this one, this one, which lie on this line are the solution of this equation. Okay, now let's suppose a circle. There is a circle, x square plus y square is equal to c square. Okay, so this circle in the graph will be represented as this one. Okay, so this distance is c. Okay, c comma 0. Okay, 0 comma c. So this circle, right, is represented by x square plus y square will be represented by this shape, where all the points in this one are equidistant from the origin. Okay, so for example this is origin, all the points in this one are equidistant from the origin and with the distance c. Okay guys, now understand the distance formula. For example, any point lie in our graph, right? So what is the distance from the origin, or there are multiple points? Okay, so what is the distance between those points? Okay, how you calculate? Okay, let's drive this. Okay, so for example, this is your x-axis and y-axis. Okay, this is x dash x, y dash and y. Okay, so any point, for example, there is a point x comma y. Okay, this a point, right? How, and this is our origin, which is 0 comma 0. So how to calculate the distance of this point with the origin? For example, okay, this is point A. So how to calculate the distance OA, right? How you will be calculate the distance OA? So this is a question. So you guys, if you draw the perpendicular, this one, okay, for example, this will lie at here point P. Okay, now in triangle this one, this triangle APO. Okay, this triangle APO, you know, this is the perpendicular, so this is x and y, right? This is the distance, x point is the distance from the y axis, so this will be x, and this y one is the distance from the x axis, so this height will be y, right? So you can see this OA, use the Pythagoras theorem here, OA square is equal to x square plus y square. Guys, just now we understand how to calculate the distance of any point from the origin, but what if we need to calculate the distance between two points in the graph? Okay, not from the origin, any two points in the graph. Okay, let's draw a graph here. Okay, for example, a point here A, which is x1 y1. Okay, and there is a point B here, which is x2 comma y2. Okay, now how to calculate the distance between those two objects? Okay, so first draw the perpendicular here. Okay, this is B, and draw the perpendicular here. This will be C. Okay, this is our x and this is our y. Okay guys, now you can see, draw this one, join this point. Okay, this distance we need to calculate, right? So draw perpendicular here, this is perpendicular, this is perpendicular here. Okay, now guys, you can see this is a point A, and this is, for example, this is point P. Okay, now we need to calculate this distance, so we need to know this one and this one, then only we can apply the Pythagoras theorem. Okay, now what is this distance? This distance, you can say this point is, this length is x, right, 1, and this length, this complete length for this point is x2, right? So what is this one? This one will be x2 minus x1. Okay, now how we need to calculate this length BP, which is this height, right? This y1, this is y1. Okay, and this point y2, the height of this B point from the x-axis, so this is y2. So what is this height is y2 minus y1. So you can say y2 minus y1. Okay. Now this one is x2 minus x1. This is y2 minus y1, and this we need to calculate. So AB square is equal to x2 minus x1 square plus y2 minus y1 square. Okay. So you will be get AB is equal to root of x2 minus x1 का square plus y2 minus y1 square. Okay, so this is the generic equation. So if any 2 points x1 y1 and y2 minus y1, so the distance between 2 points is difference between their x coordinate and then square it plus difference square of the difference of the y coordinate, and then you need to take the root, then you will get the distance between them. Okay. So this is the distance formula. Distance formula says if any 2 points generic A and B like x1 y1, so their distance will be root of difference of their abscissa and difference of their ordinate ka square, and then you will be get the root, and there is the distance between them. So this is also given represents as difference between abscissa, okay, square minus plus difference between ordinate square. Okay, so this is the distance. Okay, distance between 2 points. Okay guys, now understand with some example. Okay, so now example 1, there are 3 points and we need to find whether this whether this point form a triangle in the graph or not. Okay, for example, this is our point P, Q and R. Okay, this is our P, Q, R. Okay, draw this in a graph here. Okay, you see 3, 2 lie somewhere here, let's suppose. Okay, and 2, minus 2, minus 3, minus 2, minus 3 will be lie somewhere here. Okay, this is our origin, and now 2, 3, 2, 3 will lie somewhere here. So this is our R, this is our P, and this is our Q. So if you draw this one, okay, draw. So we need to confirm whether this is a triangle or not. Okay, now take the distance between P and Q. P, Q, distance between 2 points is difference between their abscissa, which is 3 minus 2 whole square. Okay, plus difference between their ordinates 2 minus 3, 2 minus 3 square. Okay, which is 3 plus 2, 5, 25 plus 2 minus plus it is 3 to 5, 25, and it will be root 50. Okay, PQ will be root 50. Okay, now what is the difference between PR is and R is our 2, 3. Okay, so take the difference of the abscissa, 3 minus 2 square plus 2 minus 3 square, which is 1 square plus 1 square, which is 2. Okay, so this will be root 2. Now what is the distance between QR? So this is 2 minus 2, 2 minus 2 square plus 3 minus 3 square. Okay, so this will be get 2 plus 2, 4, 16, and this will be get 3 plus 3, 6, which is 36. Okay, and this will be 52. Okay, now you guys see this is 52, 2 and 50. So to verify whether 3 points form a triangle, so some of the distance, some of the sides, right, some of the length of the side will be greater than the third side, some of the any 2 lengths. For example, this one if you add, right, root 50 plus so this will be around 749, 7 point something. Okay, 7 point something. Okay, and this will be 1.41. Okay, and this will be 7.43, 424 something. Okay, now you can see if you add this one and this one, it will be something 8.61, okay, which is greater than this one. And if you add this one 7 point this one, it will 8.41, okay, it is greater than third one. And if you add this one, also this one, this is also greater than this one. So sum of the sides of any two sides will be greater than the third side. So this is the property of the triangle. So this we confirm. Okay, this is a triangle. But let's check any other property. Okay, so you can see, if you square, right, this root 2 and root 52 and this one, if you square this one, right, pq square plus pr square, let's do this one, pq square, which is 50, and pr square, which is 2. So this will be 52, okay, and this 50, this is the length of the square of the third line, which is and qr square, if you will do, you will be get 52. So you can say this implies that qr square is equal to pq square plus pr square. Okay, pq square, this one, pq square plus pr square is equal to qr square. So this is a right angle triangle, okay, because in this right angle triangle only the sum of the two sides will be a square, sum of the square of the two sides will be equal to the square of the hypotenuse, okay, so which is qr. So this is, we proved that pr square plus pq square is equal to qr square. So this is a right angle triangle. So yes, we confirm this is a triangle and this is also a right angle triangle. Okay guys, now go to more deeper. Okay, so now we have a 4 points here and we need to draw in the graph and need to identify what shape is this. Okay, now we don't know, right, this point here, let's say it is A, B, C and D, and how to, what is the right relationship between these points, okay, what shape they will form, what the quadrilateral they will form, so we don't know. Okay, now suppose take the distance, okay, AB here, so which is 4 minus 1, which is 3, square will be 9, plus 2 minus 7, minus 5 square 25, okay, you will be get 34, okay, root. Now take the distance between BC. Okay, let's suppose the figure is like this one. Let's suppose here, okay, A, B, C and D. Okay, AB we calculated. Now BC, calculate BC. 4 minus 1 will be 4 plus is plus 1, which is 25 square 25, plus 2 minus 1 will be 3 ka square, which is 9. So this is also 34. Now take CD. CD will be this one, right, which is minus 1 minus 4, which is minus 1 plus 4, which is 3 ka square, which is 9, plus minus 1 minus 4, which is minus 1 minus 4, which is minus 5 ka square, which is 25. So here it is also 34. Okay, now take DA. So this one, so 1 minus 4 will be 1 plus 4, which is 5 ka square, which is 25. Now 7 minus 4, which is 3 square, you will be get 9, and this is again 34. Now you can see all the sides are equal. This one root 34, this is also root 34, okay, and this is also root 34, and this is also root 34. Okay, so this is, you know, all the sides are equal, but this is also can be a rhombus. Okay, so what else we need to check? Whether diagonals are equal. For example, in a square all sides are equal and the diagonals are also equal, but in the rhombus, okay, all sides are equal but the diagonals are not equal. You can see this one is smaller than this one. Okay, now we need to prove whether diagonals are equal or not. So diagonals are AC. Okay, so what's the distance of, what's the length of AC? AC will be this A and C. So 1 minus 1, which is 1 plus 1, which is 2 square, okay, which is 4, plus 7 minus 1 will be 7 plus 1, which is 8, and 8 square is 64. So this will be root 68. Okay, now calculate the distance of BD. BD is this one, 4 minus 4 will be 4 plus 1, 4, which is 8 ka square, which is 64, plus 2 minus 4, which is minus 2 square, will be 4. So this is also root 68. Now you can see all the sides are equal and diagonals are also equal, means this is a square. So this 4 point in a graph will be represented as a graph. So let's take some assumptions here. Point here in the graph, 1 comma sign will lie here. Okay, 4 and 2 will be lie somewhere here. Let's suppose this is point B, and minus 1 lie somewhere here C, and these -4, let's suppose -4 and 4, okay, lie somewhere here. So if you draw this graph, okay, so this will be kind of this one, okay. So this is a square, okay. This we already proved with using the distance formula.